Hi everyone, a very good evening to everyone. Today we are going to study about the question number 32, that is what is work done. So it's all about work done by a force. Now the very first thing is what is work? When a force applied on a particle and the point of application of force got displaced, then we say work is done. That's why work is proportional to force, work is proportional to displacement, proportional to cos theta. Here you are applying force, the particle is taking displacement, but additional one more quantity I am telling theta. So why did theta came in the equation? Because the direction also makes matter. So that is why we always have to consider that direction of force and direction of displacement, so that the angle between force and displacement is theta, on which the work done also depends. Now the next thing, when you consider work done by constant force, when F is constant, work done formula is F bar dot S bar dot product of force and displacement vector, and that is equal to Fs cos theta, where theta is the angle between F bar comma S bar, that is angle between force and displacement. So here work done by constant force. If the force is variable, then small work is FDS. Then the total work is integration dW or integration FDS or FDX from x1 to x2. So the work done by a constant force or work done by a variable force, first it will become the dot product of force and displacement for any particular displacement. And why we are taking dot product only? Because work is a scalar, force and displacement both are vectors. Now you have to get one scalar from two vectors, so that's why we are going for the method of how to get scalar from two vectors, nothing but scalar product or dot product of two vectors. That is what we are studying. Now, how to find work from Fx graph? The work done is also equal to area below force versus displacement graph. Because from any graph we can find either slope or area, and area is proportional to y quantity into x quantity, force into displacement. That is nothing but work. That's why area below Fx graph gives work done. So any graph, area means y quantity into x quantity and slope means y quantity by x quantity. But here we are talking about work, and that we can find from the area below Fx graph. And area above positive x-axis means work is positive, and area below x-axis, the work done is negative. Just x-axis you consider. So above the x-axis area is positive, below the x-axis area is negative. So this is what the simple numericals. But one more thing here, to solve the questions based on here like dot product, you need to know the dot product of two vectors. Let's take like A bar is A1 I cap plus B1 j cap plus C1 k cap, and B bar is another vector A2 I cap plus B2 j cap plus C2 k cap, implies A bar dot B bar means I coefficients A1, A2 plus B1, B2 J coefficients plus C1, C2 K coefficients. So this is one of the important definition which is used in calculating the work done. Now, when there is a work done by variable force, they will give the force in terms of displacement x so that you can go for the integration. Where the integration formula which is required is integration x power n dx is x power n plus 1 by n plus 1. This is the one formula mainly we will use in finding work done by variable force. Now, a person holds a bucket of weight 60 Newton. He walks 7 meter along the horizontal point and then climbs up a vertical wall, distance 5 meter. The work done by the man is. So he traveled 7 meter, then climbed up 5 meter. That is what they have given. Now the work done by the man. See here, here the work done by the person is, see in this case while moving horizontally, for horizontal distance 7 meter, he will apply the force upward so that theta 90 degrees. So work done is 0 because cos 90 is 0. Now while going up, force applied is up and the displacement is also upward. Then the work done is Fs cos 0. So that F into S. F is 60 and S is, he climbed up 5. So the answer is 300 joules or Newton meter. So this way you need to understand the direction. So the direction always plays important role in finding the work done. Now as I said, here the work done they are asking you to find from the graph. So here work done is area below the graph. So work done is nothing but area below the graph. Now one is A1 and another one is A2. Now A1 is area below the graph. What shape it is? That is rectangular shape. Length is 3 to 3, 9 meter square. And A2 is half into height is 3, base is 3. So 9 by 2, that is 4.5. So the answer is total work done means total area A1 plus A2, that is 9 plus 4.5, that is 13.5 joules. Now similarly, the next question is a body contained to move in y direction subjected to a force. The work done by this force in moving the body a distance 10 meter along the y-axis. So if you understand the question properly, the displacement is along y-axis, that means 10 j cap, and force they have given as minus 2 I cap plus 15 j cap plus 6 k cap. Now the work done is F bar dot S bar. Dot product means I said to take I coefficient into I coefficient. But here I coefficient 0. So minus 2 into 0. J coefficient 15 into 10 plus 6 into 0. K coefficient also not there. So answer is 150 joules. So this way dot product also plays important role in finding work done. Now here the work done by the variable force. So work done equal to integration f dx from x1 to x2, where x1 is integration minus 5x minus 16x cube dx. x1 is 0.1, this is 0.2. Now two terms are there, so write them separately. Minus 5 integration x dx from point 1 to point 2 minus 16 integration x cube dx point 1 to point 2. Now minus 5 into x square by 2 minus 16 into x power 4 by 4. So that you have to substitute the limits. First upper limit, then lower limit. So if you substitute the limits, then you will get the answer. This is how, if you know the integration, then only you can find the work done by variable force. That means the importance of integration you need to understand while calculating work done by variable force. Now, one last and final question. A lawn roller has been pushed by a gardener through a distance. So the distance is 30 meter. Now, what will be the work done by him if he applies a force of? So how much force is applying? 30 kg weight. Means the force equivalent to 30 kg weight means 30 into g, nothing but 30 into 10. And in a direction 60 degrees with the ground. So he is trying to push with some force at an angle 60 degrees with the ground. So just like this is ground and it is moving like this. So that he is pushing, sorry. So then the equation will be, the diagram will become like this. He is pushing like this. Now this angle is 60 degrees. Now this is the direction of force and this is the ground. In this direction it will move. So this is the displacement direction, this is the force direction. And this angle, it is 60 they have given. So work done equal to what? Fs cos theta. F is 300, S is 30, theta is 60. So that if you substitute F is 300 and S is 30 into cos 60. Cos 60 is 1 by 2. So 4500 joules. So this is how you need to understand how the questions will be asked based on the simple concept of what is the work done. Work done by constant force, work done by variable force, and calculation of work done from the graph, Fx graph, force versus displacement graph. So based on the same thing, I have given the assignment questions. So please try to understand and try to solve them. So thank you all of you. We'll continue in the next session with the next topic. Thank you.